All right, so I want to in Schoology. If you guys, I just want to introduce. I think I've mentioned this before. I just want to make sure I reiterate this and let you guys know that you're to be aware of this. When we're in school, so if for any reason like you miss class, especially if it's an extended period of time, and you need to stay on pace with the rest of the class, all your information is going to be in Schoology. I don't have like an online group and an in-class group for Schoology. They're just everybody that is in class or online are in the same one. Does that make sense? So you won't need to be moved in and out. I've had a couple people that get quarantined and say, "Will you put me in the online version of Schoology?" I don't have one of those. Okay. Everybody gets to see the same thing. Obviously, you know, I've been trying to, like, for instance, if we go back to this folder here where your chapter sections are showing up. The only one that has a published date on, you should be able to see all of these, but there's nothing really in these other sections yet. But you should be able to see a published date, and the last published date is the section that we are currently on. It might, I published it on 9/28, today's 9/30, but we're still on that section. Does that make sense? Okay. I click open into that. Obviously, your videos are going to be here and whatnot, and they're dated. Your assignments are here, and they're just links to Math Excel. Some of my other courses use different homeworks, so they have like 2 or 3 different types of Math Excels they have to get into, so I link all of the homework anyways for everybody. But this red link here, which isn't linked right now, so let me fix that. So this link will take you, let's see here. Yep. Yes. I'm not sure what they're, because of everything. Okay. So if you click on this top link, it will take you to my website that I've created and used in the past, which is much more involved than what you're going to see in Schoology. And you can click on the sections that we're in. So section like 2.2, okay? And there's going to be additional videos, additional examples of me. There's going to be additional videos of things from I heard some of you talking about your other classes that you're spending time researching and finding things online for yourself to get instruction. So instead of you doing that, because I go to YouTube and I've got all of YouTube, basically I've got all of the internet to search through to see if I can find something that pertains to what I'm talking about in that class. I've already done that for you, kind of narrowed your focus. So these are some pretty good videos out of YouTube that can maybe reinforce or maybe even reteach you, or if you missed, teach you initially the information that we covered in class. So that's always going to be available to you for every section. Be that top link in Schoology. Some of these videos, like it looks to me like these might be unavailable anymore. Okay, so some, obviously, depending on who they are from, they might have gone in and closed their channel or whatever. So through the years, I have to update them. Okay, so if you ever see one that's unavailable or whatever, it's for that reason. I just haven't gotten to deleting it out of this page. Does that kind of make sense, everybody? So that's there, useful. I'm kind of debating. I think I'll leave them. Videos that I've had from the past years. Okay, so these are the last 3 years of videos for classes. Be a benefit to you. And then on Schoology, obviously, I'm posting the videos of the last couple days here. Okay, so this current year of videos. Right now, Schoology, if you see this kind of stuff showing up, I don't know what this is all about. So I'm posting videos, and then they're adding just this garbage that I can't get rid of. So once the video is kind of, I can put all this stuff at the end, but I just can't get rid of it. So once the video's in, there's nothing down here that you need to scroll to find. Does that kind of make sense, everyone? Okay. That being said, we're going to actually start section 2.3 today. And I'll put all this information up for you here in a little bit. I'll give you this document in 2.3. But we're going to talk throughout this year about several categories of statements, types of statements, okay? We've already seen one type of statement called postulates, or we have also seen them called axioms in some context. And those were accepted truths, things that we cannot prove, okay? So we have to agree that, yes, this is a fact, but there's no way that I can kind of stack previous information on top of each other, combine previous information, that sort of thing, to actually provide a logical reason of why it's true. But it makes sense that it is true. Does that kind of make sense? Okay. The other types of statements, and we haven't seen these yet, okay, but theorems are a huge portion of this class. And theorems are accepted truths as well, but we can prove those, okay? We can use previous statements, previous definitions, previous postulates, previous even theorems, and we can tie them together, and they can make a new statement that is true. And that new statement that would be true would be called a theorem, okay? Corollaries are another type of statement, okay, sometimes called lemmas, okay, but they are accepted truths as well, but we can prove them easily from a parent theorem. So whenever you see a corollary, there is usually a theorem that was more broad, in which that corollary is much easier to prove because of that theorem. So one of the theorems that we're going to see eventually is that there's 180 degrees inside a triangle, if we add up all the angle measurements, okay? A corollary to that, or a lemma to that, is that an equilateral or equal angular triangle, which means all the angles are the same, right? Okay? Each one of those angles is 60 degrees, because 180 divided by 3, finding the average essentially, is 60, right? Does that make sense, everybody? So that statement is actually a corollary because it's easily proven using the fact that all three angles in a triangle add to 180, a previous theorem. So we'll have corollaries and lemmas. This class doesn't use the word lemma. The text doesn't use that very much. The text doesn't use axiom very much. But if I have a PDF from something, or I have an excerpt from another textbook, or you get into another class and they start using these words like lemma and axiom, and you've never seen that before, that's hopefully giving you a little bit of experience with it here. Can help you remember what they are. And the one that we probably have the most experience with, because of what we've done in other classes, are definitions. Okay, definition, and in this, I'm going to read a document that I've written out for you here to you in a moment. But definitions are statements that categorize and identify objects. Okay, it's a statement regarding the exact meaning of a word. Okay. What is important is that we're able, I'm not a huge stickler on being able to.
Pardon interruption, but with the homecoming court, please report to the gym at this time. For more pictures, again, with the homecoming court, please report to the gym at this time. Thank you.
I'm not a big stickler on your ability to differentiate whether a particular statement that I've given you, if you're able to identify it as, was it a postulate, was it a theorem, was it a corollary. When I am going to ask you to prove like a theorem or a corollary, then obviously it eliminates the potential of it being a postulate because you can't prove those. We don't prove definitions either. But it's going to be important for us to be able to recognize what a definition of a word is. Okay, so those types of statements are going to be very important to us. Okay, now this might, what we're going to talk about here might seem like something that you guys don't full, and just because of my experience teaching this for 13, 14 years, I know students don't take my word for it when I tell them definitions are important. Okay, we can't forget definitions. Think about this. If I start talking about asking you to take the apothem of a regular polygon and multiply that by the tangent of 60 degrees, something like that. Okay, do you know what an apothem is? Do you know what a regular polygon is? Okay, do you know what tangent is? Okay, so those are 3 vocabulary words that you have no idea what the definitions are, so you have no idea, you cannot operate within that problem. Does that make sense? Okay, and that's one of the huge issues with people not learning definitions, is that they don't allow, if you don't know them, it doesn't allow you to move throughout mathematics. Okay, so as, and I don't want to read this word for word, the whole thing at least, it says definitions are the foundation of mathematics. Okay, geometry bulges with definitions, and one of the biggest challenges you guys are going to come across is the ability to master them. Okay, we have to have dialogue. We have to have discussions. I have to say things, and you have to know what I'm saying, right? The only way that you're going to know what I'm saying is if you know the individual words of each statement. Okay, it says too many students address that difficulty by complaining about the questions on exams and asking about precise definitions, and the argument is always it's not mathematics, okay? Or this class seems like it's an English class or a grammar class more than it does mathematics, okay? You might say you understand a concept, but you don't know the definitions, and that to me is kind of a con statement, because if you don't understand the definitions, it's guaranteed that you're not going to understand the concepts. Okay, but I hear those excuses all the time. I haven't heard those from you guys yet. I just want to keep your eyes open to the importance of definitions. Okay, so the assertion that definitions or asking students to know them is not mathematics seems to rest on the fact that prior to geometry, you guys have your experience with math is simply calculations for the most part, being a calculator. Does that make sense? Okay. Think about algebra last year. Most of the things you did, adding, combining like terms, isolating variables, and that sort of thing. But that was heavily inundated with calculations. Okay. Everything prior to that was usually calculation, because what you're doing is you're trying to build a foundation in your previous courses so that we can get to high school mathematics and actually use our ability to add, subtract, multiply, divide, any types of numbers to kind of explain and understand other concepts in math, more difficult things. Okay, I think this is one of the most important statements here that we will come across. It says mathematics is developed to avoid or simplify calculation. Okay, mathematics is developed to avoid or simplify calculation. You're going to hear me say that mathematicians are lazy. Okay, think about this. You guys, what's the first thing you guys ever learned how to do in a math class? Before that, count. Okay, you learned how to count. You learned how to say, 1, 2, 3, 4, 5, 6, or whatever. Identify how many things are in this box or whatever. How many apples are on my desk? That kind of thing, right? You count 1, 2, 3, 4. Then you learn to add and subtract, right? What are those things? What is adding and subtracting? Okay. Counting up, counting down. Think about this. Let's say, let's see here. I'll write this on the board so people that are at home can see this. Let's say I've got let's use, I'll just use circles here. How many circles do I have there? 8 circles. Okay. If I do this, wipe those away, how many do you have now? 6. Did anybody count 1, 2, 3, 4, 5, 6? What'd you do? You started with 8, you took 2 away. You did subtraction, right? But it gave you 6, which is exactly what I get if I count these, right? So subtraction is a more efficient way of counting. Does that make sense? It's a shortcut to counting. All right. If I had something like this, let's say I've got how many groups of 3 do I have there? I have 5 groups of 3, right? So how many circles do I have? 15. We just did multiplication, right? Is that a shortcut to going through and saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15? So multiplication is a shortcut to avoid counting, right? What about division? Let's say I do this. Let's say so I've got how many? So right now I've got let's see here, 1, 2, 3, 4, 5, 6, 7. I got 7 columns of 3, so I got 21 things here, right? Okay. If I asked you a question, what is 21 divided by 3? You know that to be 7, right? Let's talk about what subtraction is. Okay. Keep track here for me. I'm going to take 21, or what division is, I guess. Take 21, and I'm going to subtract this group of 3. And then I'm going to subtract that group of 3. And we'll subtract that group of 3. And I'll subtract that group of 3. Subtract that group of 3. Subtract that group of 3. And subtract that group of 3. How many groups of 3 did I subtract? 7. And I got when I subtract those, I get then an overall value of 0, right? So division is repetitive subtraction. Does that make sense? Okay. 21 divided by 3 gives me 7. Means then if I take 21 and remove 3 from it, it's going to take me 7 iterations of removing 3 to get down to 0. Okay. So my hope is that you realize, okay, well, we've learned how to count. Then we learn how to do adding and subtracting, which is a quicker way of counting. And then we learn how to do multiplication and division, which is a quicker way of doing adding and subtracting, which would ultimately be even a quicker way of counting. Does that make sense? So everything that we've learned from day one in mathematics is built off that principle, that idea that mathematics is developed to avoid or simplify calculations. Math is not about doing the calculations. It's coming up with strategies, techniques, concepts that allow us to simplify those operations and those calculations. Okay? It says the theorems are powerful tools that allow one to finesse and minimize calculations. Finesse and minimize work. Okay? So the definitions encapsulate the concepts and provide students with a framework that builds new concepts. Without definitions, concepts cannot be introduced, and student proficiency within concepts is limited. Okay? When we talk about definitions in this class, we have to remove ambiguity. You guys know what ambiguity is? Or being ambiguous. Let's say that I have a friend, and their name is Pat. Do you know if Pat is male or female? No. Okay? There's ambiguity in that name. It's left open to interpretation. Okay? You need more information to be able to make a decision, right? Okay? If I tell you that my friend's name is Patrick, now do you know male or female? I gave you more information, right? I've eliminated ambiguity. Okay? If I say right now would you guys agree that I'm close to Jagger? Standing here? Am I still close to him? Am I still close to him? Am I still close to him? Still close to you? Okay, so let's say I step here. Let's say now I'm not close to you. So here I was close, but now I'm not close. Where was that breaking point? Does that kind of make sense? What allows me to draw a line and say, this is no longer close and this is far away? Using words like that in definitions creates ambiguity, okay? If I said, like, I'm going to define something in, let's say I'm going to define what a giraffe is. I think I use that example later on. And I say it's a big animal, okay? Big is vague, okay? Does that make sense? Okay, because depending on how big you are, or depending on what you think is big, white might change the way you view what I mean in that definition and what your neighbor means in that definition. Does that make sense, everybody? Okay. So it says in casual conversation we could tolerate a fair amount of ambiguity, okay, but in mathematics you can't, okay, and in law we can't, okay. If I'm trying to defend somebody or prosecute somebody in a law case, being vague is a problem, okay. So if a newly introduced term theorem uses the word parallel, we all need to agree on what parallel means, okay. You guys, for parallel, what does parallel mean to you? What have you learned in the past that parallel is? Okay, two lines that never cross, right? That's a very, very bad definition for parallel, even though it's what you've been taught for your entire lives, right? Okay. I'll show you why that's a bad definition. So if we look at these lines over here that I just created, okay, you see that black line, the two black lines, right? Okay. Would you agree that those two black lines do not cross each other? They do not touch, right? So by your definition that you told me parallel lines are lines that don't cross, that would mean that those are parallel lines, okay? But furthermore, when we have things that are parallel, think about like railroad tracks or like a ladder or something like that, or the grid on the ceiling right now with the tiles, is the distance between, if you look at the grid on the ceiling, are the distance between any two lines that are going from the wall on the smartboard is on to this wall back here, are those distances the same all the way across? And that's a key concept about parallel, okay? If I look at these two black lines, and you stand at any one of the points on either of those two black lines, so I stand at this point right here, and I ask you to get to that line, okay, the distance you travel there, and we'll talk about how we would talk about that distance later on, okay, that distance would be different than going from this point to that black line. Does that make sense? Okay, so these are not parallel lines. They don't touch, but they're not parallel. So our definition of parallel needs to eliminate the potential for this to show up, the potential for this to be classified as parallel, okay? So what we do is we say that parallel lines have to be coplanar, okay? Meaning they have to be in the same plane, like these. This is now just one two-dimensional plane, right? So now I've got this line here and something that would be parallel to it, okay, that line, and now those are parallel. There's no chance that one of those lines is like coming at you and going away from you, and the other one's going left and right, correct? Okay, so we change our definition by adding that one word coplanar, and now that image here gets excluded, and that never becomes classified accidentally in my definition. Does that make sense, everybody? Now, you might be asking, well, why didn't they just tell us that when we were first learning what parallel was? When you first learned what parallel was, maybe in like the 5th or 6th grade. And at that time, your brain's not fully developed to understand what coplanar meant. Does that make sense? So they eliminate that. You didn't work with three-dimensional things. And to be honest with you, research says it's not until you're about 26 years old that your brain is fully developed to where you can really understand the mathematics that we talk about in high school, which kind of stinks, but it is what it is. So it says, if a newly introduced term or theorem uses the word parallel, we all must agree then what parallel refers to, so we can apply a new term or theorem later on that uses that same exact term in the same exact manner. It says mathematics builds new ideas on already established ideas. Okay, it's the idea that tomorrow's stuff that we learn is going to be based off what we learn today, right? Because we cannot build new ideas on it depends what you mean. Okay, I can't build, if we're talking about how close I was to Jagger, we can't build a new idea that builds on closeness if I can't establish what closeness really means and how we kind of classify it. Okay. We can't share our discoveries with others unless they agree on the same meanings of the words that we use. Okay, so I'm going to show you some things down here that are some pretty poor definitions. Okay, and a couple that are good definitions. One thing says we must learn to distinguish that the definition provides a mechanism for classifying objects and identifying what those objects are, while at the same time eliminating multiple and different objects from garnering the same classification. So that's the idea that I don't want these lines here to be represented or labeled as parallel when I know that they're not. Does anybody know what those kind of lines are called, those black lines? Starts with an S. Have you ever heard the word skew before? Okay, those are skew lines. Okay, you guys ever heard of like when you grill, on the grill, you put a skewer through like your meat or your vegetables or whatever? That word comes from this idea here. Okay, and we'll talk about that later in chapter 3. All right, so definitions in mathematics should be precise and unambiguous. Okay, so precise means the idea that I cannot use the word like large or small or close or near or far. Those are not precise. Okay, if I'm going to do something like that, I need to identify that close means I'm within 5 feet of somebody. Now I've identified what close means, and now I've identified what close does not mean. Does that make sense to everybody? Okay. So definitions need to be precise and unambiguous. In practice, this means that definition should tell you exactly what you need to do to determine whether an object does or does not fit the definition. Okay. So the formal definition is based upon a concise logical pattern that includes as much information as it can within a minimal amount of space. So think about this. We don't want to write a definition that takes half the page in the dictionary. Okay. We want a definition that is minimal, but tells me everything I need to know. Okay, that's what it means by concise, right? So the primary reason to include definitions in your writing is to avoid misunderstanding with your audience. Okay, if I'm writing to an audience, if I'm talking about something, and I write a paper, and you guys are my audience, you read it, and I use words in there that you guys don't know, I need to be able to define those for you, right? That makes sense? I need to be able to tell you what those words mean so that you can understand the rest of my paper, okay? So the formal definition consists of 3 parts. Obviously the term, okay? The class of object or concept to which the term belongs, and then differentiating characteristics that distinguish it from all of the other classes, okay? So when we talk about differentiating characteristics, they are used so that other possible objects are not categorized by my definition on accident. Okay? So here's an example. If I want to define water, okay, if I just say water is a liquid, there's a lot of things that are liquids that are not water, right? That makes sense? Okay? So a lot of things would accidentally get classified as water but not really be water. Okay? So I say water is a liquid, that's a class. It says made up of molecules of hydrogen and oxygen. Okay? And if I stop there, okay, there are other types of water that we don't drink because they're toxic that are still made up of hydrogen and oxygen. That makes sense? Like different isotopes of water. You guys probably learned that maybe in chemistry. Okay? So is a liquid, which is a class, made up of molecules of hydrogen and oxygen in the ratio of 2 to 1. And that 2 to 1 is the differentiating characteristics, right? Okay. So now we are able to identify a water, we know what it is, And it also allows me to say, okay, if I come across, let's say, hydrogen peroxide, I know that hydrogen peroxide is not made by H2O, right? Not 2 parts hydrogen and 1 part oxygen, okay? That would mean I cannot classify hydrogen peroxide as water. Does that make sense, everybody? Okay. Says if you were to find water as a liquid made up of molecules of hydrogen and oxygen, you do not differentiate enough to eliminate the possibility of having different molecular structures that produce a different liquid. Okay. So if I said, this is the one I always use in class a lot, a giraffe. I just say a giraffe's a 4-legged animal. You walk by a pig farm, you could say each one of those is a giraffe, right? And we would know that would be wrong, correct? Okay. If I say it's a giraffe is a 4-legged animal that lives in Africa, okay, that means maybe a zebra accidentally gets classified as a giraffe, right? So we want to make sure that, you know, when you guys are naming your animals, you go to like the kingdom and the phylum and all that kind of stuff that you learn in science, right? Okay, and that would be their class and distinguishing characteristics, all that kind of stuff. Mailbox. If a mailbox was, by definition, a place to put mail, okay, then the post office would be considered a mailbox. The post office truck would be a mailbox, okay, and those are not true things, right? I put mail on my desk all the time. That means that my desk must be a mailbox. Those things are not, those are too ambiguous, okay? We need to be better at classifying what is a mailbox, what is a giraffe, what is parallel lines, that kind of thing. Does that make sense to everybody? Okay. I'm not going to go through all of these here, but if I say a line, these are some things that we've talked about. Line says points that connect and go on forever. Okay. That doesn't differentiate on direction and orientation of the points. Okay. That doesn't tell me that the points might be up and down from one another. Okay. And create like a wavy line or a curve, and we know that that doesn't meet our definition of a line. If I say a plane is a two-dimensional analog of a point, okay? It says, would I have to determine what analog meant? Does that make sense? Okay, so sometimes when we write definitions, why are they bad definitions? Is because they use words that are not formally known. Does that make sense? Or commonly known. You guys have probably done this. You've been reading. I do this all the time. When I was in high school, and we'd read a book in Mr. Ellington's class or whoever's class, and came across a word I didn't know. What do most of you do? No, you don't. No, you don't. You just skip it, don't you? I skip it. Like I'm not gonna take the time to go look it up. You're told the right answer is look it up, or maybe read the context around it, and you can get an idea what that word means. But I know a lot of us don't go look it up, okay? Because one word out of an entire novel, maybe it's not a big deal. Maybe it is a big deal, okay? What's that? Okay, all right. But if you look at a definition and you come across like 3 or 4 words in that definition, even one word in that definition that you have to look up, now you're playing that kind of that piggyback game where, okay, now I don't know that word. I got to go look it up, read it, understand what that word is. Now come back to the definition I was really interested in and try to learn that definition I was interested in with now a larger vocabulary. Does that make sense? That's kind of hard to do. That's a pain in the butt. So we like to write our vocabulary words with terms that are commonly known, okay? You know, we want to eliminate vagueness. It says angle bisector here. It says divides an angle into 2 parts. That is something that it does, but it's vague because it doesn't tell you what we need to know about those 2 parts, okay? Those 2 parts have to be congruent in size, right? A poor I guess I'm trying to think if I have anything written here. No. An alternative that we see quite often is, and you actually will see it in some of the vocabulary words that I present to you in this course, because I want to make you guys aware that even though this is a very common practice to avoid, people still do it, and it's dumb. And I want to make sure that we highlight it and you see it, and you see, okay, this person is a very intelligent person who wrote this textbook, but then they write a definition like this, okay? Definitions that use the word that you are defining inside them. Have you ever come across something like that? Okay. Well, if we're defining complementary angles, and I just said complementary angles are two angles in which they are complement to one another, does that get you in kind of a loop? Because you're looking up complementary because you don't know what it is, but in that definition it says complement. Well, that gets me now. I got to look up complement. It took me back to the word I'm looking at, right? We're trying to figure out in the first place. So it gets you in a loop, and that's a problem. But there are some definitions that are written that way. That's a terrible thing to do. You never want to write a definition and inside the definition use the word you are trying to define, even though it happens. Okay. This kind of makes sense? Okay. Now, would you agree that there wasn't a whole lot of calculations being done in that discussion? Okay. It's very, very, very important for us to understand what definitions are, because they are the building blocks for everything else. Okay? You're going to see vocabulary on all your tests and quizzes. There's going to be vocabulary and an understanding of your definitions. And even if you go back to other math classes so far, think about going into maybe Algebra 2 or college algebra or trigonometry or stats or whatever. Okay? If I'm in college algebra and I ask you to look at this, I'm going to say look at this polynomial equation and come up with this polynomial equation is a third degree polynomial, and I want you to determine what the three roots are. If you don't know what polynomial means, you don't know what equation means, you don't know what a root is, are you going to be able to do that problem? No. Okay. Now, I don't. In those classes that I teach, I don't ever do vocabulary with them on tests. I don't say, tell me what a polynomial is, tell me what a root is, that kind of thing. But I will write my questions on purpose with instructions that use the vocabulary that we've been using throughout the chapter. Because if they don't know that vocabulary, it puts it on them that they're not going to be able to do the math, right? Or calculations, I guess, okay? Because the vocabulary is math. All right. So that's the number one thing I want to get through to you today. Definitions are important, and definitions, though they are English, they are grammar, they are statements, they are mathematics. Does that make sense to everybody? Okay. And they allow for the rest of mathematics to exist. All right. We'll stop there today. I think you guys still have that assignment open from 2-2. If you guys want to work on that. Does anybody have any questions on it? We can talk about some specific questions on it if you have them. If not, if you have individual questions, you come see me, talk to me about them. I can help you out one-on-one. All right? Tomorrow we'll pick up with 2-3 and talk about biconditionals and how those relate to definitions.